All right, I guess we'll get started. Okay, so we'll recap in just 1 second, but I just want to do some quick housekeeping before we actually get into this stuff. Okay, so if you take a look at Blackboard, I've uploaded the assignment too. Some of you have actually already taken a look at it beforehand, but just keep in mind that it is there. You can find it under the assignments folder, or you can find it in today's lesson. Either way, you will see it there. Okay, so we're going to talk about it real fast. So this part here just shows you the basic instructions, but you want to look at the PDF because in the PDF is the actual rubric. Okay, I don't generally use Blackboard's rubric system because it sucks. I find it easier just to create a table and do it that way. All right, cool. So what your assignment is. So this assignment is a little different than the assignment we did the last time. The assignment we did the last time, I basically laid out some steps. You went through step 1 through to 20 something or whatever and completed the steps, and then you handed it in. The problem with that, I find, is that one, it doesn't teach you to think on your toes or think for yourselves, right? It's basically just me giving you a step and then you kind of look it up and then fill in the details. I think it's much better and more beneficial to you, and definitely a disservice to you unless I do this, for you to think on your own and think on your own feet and actually come up with a solution to the challenge on your own. So because you have to come up with your own solution, I've allowed you in this particular assignment up to 3 group members. You don't need it though. Like, this is an assignment that you could probably complete in a weekend, no problem. But you can have up to 3 group members to work on your assignment. You can talk to the other class, my Monday class. Obviously, it has to be my class though, right? So I have a Monday class that is in at 5 o'clock. If you know any of the people in that particular class, you can work with them as well. Just make sure I know that. It needs to be in a README file just like the last time that basically states who your group members are. If they're in the other class, whoever submits needs to state that it's so-and-so from that class. That's very, very important. But you can work with people from the other class. All right, cool. So I'll tell you exactly what it is. You're going to create a fun and interactive math game for kids that allows them to practice their basic math skills. So the only math you need to concern yourself with is calculus, physics, no, I'm fucking with you. Just addition, subtraction, division, and multiplication. That's it. That's all you need to do, okay? So just very basic math. So you're essentially going to have one number here, whatever the actual equation operator is, and then another number here. That's it. Very basic. You're going to create an interface that shows a math equation and allows a user to enter a number to solve it, so they need to be able to enter the answer, right? You'll need a button that the user can click to actually submit the answer, or if you want to get kind of creative and make it so that when they leave the field, which is an on-blur event, you could actually immediately evaluate the answer the second they leave the field. Totally up to you. The interface should have a scoreboard that should update on correct answers and decrement on incorrect answers. Okay, so increase the score when they get it right, decrease the score when they get it wrong. The user should have the option to skip the question for no penalty. Now, you don't have to like go back and figure out, okay, well, how many times have they answered this, and this is the number of score that they lost, so now I got to put that back. It's not like that, okay? Just if they click skip, don't increment or decrement any further, just move them on. There should be a message section for giving feedback to the user, just basically a correct or wrong answer. That's all you need to do. Just give them feedback. All right. There's no hinting in this one, nothing like that, no crazy logic. However, I want you to use a function constructor because we're going to do object-oriented in this. I want you to make prototypes, so anything that's a method needs to be a prototype that's on the function constructor. Okay. If you forgot how to do that, go back and visit week, I want to say 6. Probably wrong, but I want to say 6. All right, you'll need a prototype for adding, subtracting, dividing, and multiplying. These prototypal methods will basically be your way to evaluate the equation, right? You should be able to take a look at the numbers and use one of those in order to solve it, and then use that to evaluate the user's answer and see if it is correct. You'll need to create event bindings for the button that does the evaluation and the button that skips the question, and any other buttons you decide to build, because it's completely open-ended and you can build whatever you want. You will need a prototype method that evaluates the equation in the user's answer, obviously. You're going to need a prototype method that executes when they win a question and when they lose a question. You will need to create a prototype method that generates a random addition, subtraction, multiplication, division question and populates the interface with the equation. And you need to store the user's current question, score, and any other details you feel important to the user session in local storage. Now, this is basically just an outline. You don't necessarily have to have a prototype method for subtracting, dividing, multiplying, and adding. You can build what you want, but at the end of the day, you need a function constructor, and any method you create has to be the prototypal method on that constructor. That is the important takeaway from this, okay? This is just trying to help you out, give you ideas of what you will probably likely need as components in order to complete this. Your interface, you are required to add some style and pizzazz to the interface. The more interactive it is, the better, right? So obviously it's a 15%, so it's a pretty hefty mark. If there's 3 of you in your group, it should be pretty stellar. All right. You may have groups of up to 3 people. You must submit a README file detailing the members of your group. Your application must be compressed and submitted to Blackboard. Don't give me the main JS file because I don't have your index HTML, so there's no way I can put this thing together. You need to give me your index file, your JS file, and your CSS file, or whatever structure you've created, or a link to your website plus the compression of your assets. So in the past, I've had students give me links to Code Playground. You guys ever used Code Playground before? So it's like a sandbox where you can build like React apps and stuff. I've had people in the past give me links to those, and that's totally fine, but I do still need your compressed copy of your application, okay? It is convenient though, and I do like it, so if you want to use the Code Playground, please do, because it makes it a lot easier than me having to download your stuff and unzip it and everything else, but yeah. Okay, bonus marks are awarded for going over and above. You can get up to 20%, so anybody who actually needs bonus marks, this is the place to find those. Non-working code, however, will be penalized 20% immediately. So if I open up your application and it's just dead right from the get-go and I've got to go chase down exactly why it's dead, yeah, I'm going to penalize you for that, up to 20%, depending on how hard it is for me to figure out what's wrong with it. Interaction. So scoreboard shows the score to the user, a message so that you can give some sort of feedback to the user, the equation, and then whatever actions you're going to have. Your application needs to be a function constructor. You have to be able to basically equate and add, subtraction, multiplication, or division equation in some way. You need event bindings. You're going to need a random equation generator. You will need an evaluation method. You'll need win-lose methods, and you'll need to use local storage. Did I say that part? Oh, yeah, that's the last thing. You're going to need to store the user's current question, score, and any other details you feel that are important to the user session in local storage. Don't be nervous. That's today's class. We're going to learn about local storage today, so not a big deal. And it's surprisingly very simple to work with local storage. What else? Yeah, 15% is into your page structure. You must contain the scoreboard, message section, action buttons, equation, and answer input. Your styling is present and logical for the game. Because some people try to just give me a background color change and some font changes and expect that to be like cool. It's not. You need some decent styling. Don't just dump Bootstrap in there. Any idiot can put Bootstrap on a page. I want to see like, you know, some coolness, you know, be creative, enjoy it. Buttons and interactive elements are known using hover elements or hover events. So what that basically means is that when I go over top of a button, it should change color. It should do something so that I know that that is a button and that it's interactive. So you definitely want to use those interactive elements that you guys would have learned in your HTML classes. So cool. An additional 20% can be earned by going over and above. Try adding a reset button that will allow the user to reset everything. So they've been playing along, they're incrementing, decrementing their score, and then they decide, you know, I just want to start fresh. I want to start from scratch. So they click the reset button, the score resets to 0, all their past questions are wiped, their local storage has been wiped, and they're ready to start from 0. That'll earn you 10% of a bonus point. However, if you want to go even above that, You could try making it so they can do multiple save states. So say there's more than one user and they want to save their version of their game. You could do that using a combination of local storage and some interesting logic and make it so that they can actually save multiple states of the game. And if that's the case, that's definitely worth 20% to me. So, and it's actually not even that hard of logic to implement, but I figure if you can think that far above the box, then that's cool. All right, any questions about the assignment 2? Its due date is April 14th. So, and there's no extensions. There can't be because the grades are due April 19th, which means I only have 5 days to mark 82 of them. So there's no extensions on this whatsoever, so I recommend you start ASAP, okay? If you want to do something other than the math game, I have one student who's building a platformer game where you're like a little character and you walk across the screen, you have to jump obstacles and stuff. So obviously that's way out of the realm of this, but that's totally cool. If you want to take this opportunity to build something very different, maybe you want to learn React or you want to learn Angular or something else and you want to actually explore that avenue, that's totally cool. Make sure I know in advance. Send me an email or send me a message on Slack or talk to me today and say, this is what I plan on building. I'll give you the A-OK, and then you can go ahead and build that instead if that's what you want to do. Okay, so just let me know. Otherwise, I expect to see, 30 of these nearly? 20 of these? 25 of these? Cool. No questions, eh? Not a one. All right. I got questions. I just don't know how to ask them. All right, so it's up there for you. And like I said, you can work with other people in the other class if you want to. That's totally okay. All right, let's talk about last week. So DOM events. Right? DOM events are the interactive events, right, that you have in the page. When you hover, when you click, even when the page loads, these events are automatically being triggered using the event system. So the event system is underneath the hood, and it's basically listening for different events that occur. And when those events occur, it will basically fire off any registered functions to those events. It does work within an ancestral tree, right? So if a click event happens on a button, anything within that click event's ancestral tree, so its parent, its grandparent, its great-grandparent, will fire off any registered functions if they're subscribed to the click event as well, but only within the ancestral tree, right? So last week we introduced this whole thing, and it's integral, right, to being able to work with the interactive web, to be able to do any type of interaction with your user. You are definitely going to be using JavaScript. I mean, you can do some interactions with CSS, and there are CSS Puritans out there who, you know, they build image sliders purely in CSS. They build cool little click boxes for checkboxes purely in CSS and stuff. But, I mean, JavaScript does make it much easier. Doing any of those type of things in CSS is a lot harder. So JavaScript does make life a little simpler, I find. Yeah, and it's basically almost always available to you. We talked about how the event binding cycle works. Basically, you select an element from the DOM or the DOM itself. You bind an event listener to that element, and then you register a callback to the bound event. Now, you don't actually have to bind the event listener. That part is almost optional. Because if you're using like on click, on mouse down, on mouse up, any of those guys, they're already bound to that DOM object. They come with it as a part of the event target because they inherit from the event target. So they're already bound to it. They just don't have any registered functions on them, right? They're all currently value null. Remember those event properties that we talked about? That's what we're talking about here. So they're already bound to it. What this is basically talking about is add event listener, right? Add event listener is binding an actual event to a DOM element and then registering a function to it at the same time, which we talk about a little further down. All right. Cool. We made this wonderful little click me button that currently doesn't do anything because I erased everything. We talked about the event target. So when an event is fired, the registered function is passed an argument automatically, and that is the event object. The event object gives you a bunch of information. It tells you where the event occurred. It tells you the path. We found out today. It tells you the path that it actually was clicked on. So whatever element was clicked is first in the path, and there's a whole bunch of different other things, which I didn't even know about. We just found it accidentally. However, it also gives you information about the actual target, right? So whatever called the function, whatever DOM element had the function register it, will fire off, and that is the event target. Probably the most important part in the whole situation, because you need that if you're pulling back lots of the same element and you have registered a function to all of those elements on the click, and they're kind of, they're all basically the same type of element. They look like clones of each other. It's kind of difficult for you to be able to figure out which one was clicked programmatically. Event target makes that a lot easier for you so that you can easily isolate it and then make any modifications you want to it. Yeah, like this big thing right here where it's supposed to change colors. We talked about event dispatching. We talked about event bubbling, which is where, because of the events being called up through the ancestral tree, sometimes you need to prevent that bubbling so that when the button is clicked, it isn't calling every single parent registered function all the way through. It will stop at that one particular thing, and we use the command stop propagation to do that. We talked about stopping default actions so that when a link is clicked, it doesn't actually navigate away from the page and go somewhere else. Instead, you can actually perform other logic and prevent it from doing its default action. Same with like form submissions, right? Because when you click a form submission, it will attempt to, submit the form to whatever action you have defined in its action attribute. However, if you want to prevent that, then you have to use prevent default to stop it from doing that. And that is very common because if you build a web form, often you're going to need to validate it. The Chrome validation is pretty good, but for the most part not perfect, and so often you're going to want to be able to validate your own things. Generally, when you're trying to make two fields dependent on each other, then you're going to need some custom logic, and you can only implement that with JavaScript, and you are going to have to prevent the default submission in order to do that. We talked about the 3 different ways to bind events. Add event listener is probably one of the more common ones you're going to see on the web. However, with the on-click, on-mouse down, on things like that, they are a lot more convenient, as far as I'm concerned, to use because they're already registered to the DOM element. It makes it very simple to work with. All you have to do is make that property equal to a function. The second the element is clicked, it will immediately call whatever that function is, which means you have automatic action for it. However, it's important to understand that this is a one-time bind, so like when you actually register the function to it, you only get that one function call. If you register another function to it, you've now replaced that value entirely with the new function. If you want to have multiple functions registered to a DOM element on a click event, what do you need to use in order to do that? If you want to have multiple registered functions on a DOM event. Yeah, add event listener, because add event listener will let you constantly register brand new functions to it. There is one caveat to add event listener though. That's add event listener registered functions cannot be removed if they are unnamed, right? So if you use an anonymous function to register your function to the DOM element, what will happen is if you want to remove it, you need to be able to tell the event system which function you're attempting to remove, which means it needs a name. You have to give it a name. So that's not a big deal, and often you're not removing them. It's very rare that you do, but there is times where you need to, so just keep that in mind. And that leads us to the removing events, where we show you how to remove events using the event properties, removing events using the remove event listener, and removing events using HTML attributes. Events applied with HTML attributes, it's no different than events applied with the event property system. They're exactly the same thing, just one is in line with the HTML, where the other one is actually done directly in the JavaScript. The only thing to keep in mind with HTML event attributes like this here, any JavaScript inside here will be executed. It's just a string, which means anybody can inject whatever the heck they want in there, and it basically just full out calls eval on it, which eval is bad, right? Because eval will execute anything in there as if it was JavaScript. So you need to be cautious about that from a security standpoint. This is not necessarily the best way to do this. if you want to bind like delete checks and stuff like that, either your user is already logged in, so you don't care if they want to screw themselves over, they can go ahead, right? Or you're paying attention to those things and you're putting them in isolated environments. So those are things you need to be concerned about before you just automatically execute random JavaScript that you don't even know where it came from, right? Cool. That is DOM events. Any questions about DOM events? So this thing is definitely going to be, DOM events is definitely going to be your best friend during that assignment because you're going to need to know how to bind click events, right? And any other type of event. And that article, which I'm thinking I'm going to put into a textbook at some point, because my God, like I've written like 12,000 words at this point. So yeah, definitely keep track of that. And then today's is also going to be important to you as well, because we're going to talk about self-describing data. The two classes that follow this, they're not throwaway classes, but they are not necessarily going to be, no, they won't be. They won't be on the final. And they are client-side API and server-side API. The only reason I don't put them on the final is because it's more like my introduction to those two different classes, because next semester when you take advanced frameworks, all you're going to be doing is API stuff. You're going to be constantly working with API. So to me, it's kind of like just a debriefer before then. So the last class, we will probably do the server-side API, connect to a server, create something. I think we're actually working with Google Maps. We're just going to connect, make a Google map, that kind of thing, which means we'll have a good chunk of the class left over. And then during that, we'll do a test review so that you guys are ready for the final, which will be the following week. Okay? So that's in the next couple of weeks. Cool. All right, today's class, we're going to talk about self-describing data and client-side storage, which are kind of two pretty fat subjects for the most part. And I know Monday's class went almost the whole 3 hours, and that was with us like motoring along and skipping a break. So it just depends on how this today will go, but hopefully it goes pretty smooth. Self-describing data, in case you don't know what that is, that's data that we generally transfer around and use in order to create dynamic structures, use existing structures but create dynamic information. I think I called it dynamic content generation in here. Self-describing data, you guys have already used it, despite whether or not you realize. XML, for example, I think I've told you guys before, you've already used XML. If you've touched HTML, you've used XML. That's just the way it is. HTML is XML based. HTML is used to describe XML or describe the data that's on the page, right? So you've already done that. And then the other piece that you guys have used that is technically self-describing data as well is databases. You guys have all done databases. Anybody here not done a database? Yeah, exactly. So you've all worked with databases before. When you retrieve back those records, that structure that you get back with all your different rows is a self-describing data structure that you are now working with, right? But usually when we're talking about self-describing data from a client-side perspective, we tend to be only ever talking about pretty much these two structures, which is JSON, right, which stands for JavaScript Object Notation, and XML. Those are the two that you will see primarily in the wild. There are a few different types of ad hoc ideas, but from a client-side perspective, it becomes it becomes more difficult to work with ad hoc solutions because you have to build custom parsing solutions in order to work with those. So it's from a developer standpoint, from like a sprint or anything like that, it doesn't make sense for your CTO or your technical officer to do that to you, because it just creates, it just causes inefficiencies. It just makes things take longer. Might as well use things that exist, like JSON and XML. So here there's two examples. One example shows you what XML looks like. I mean, shouldn't be new. It looks just like HTML, except for there's some bizarre tags that maybe you haven't seen before. And that's because those tags are made up, right? Because you can literally make up whatever you want. As long as you put an opening one and a closing one, you can literally create whatever tag you want. Totally fine. It does follow the same conventions as symbol naming, though. That's important to understand. So no spaces, right? You can't have any white space characters in there. No unique weird symbols. no @ symbols, nothing like that. You cannot have attributes. We gave it a go on Monday because people were like, well, if it's HTML, can we do attributes? We tried it. No, you cannot. It breaks it, and it actually results in an error. And then on the other side is JSON, right? I mean, if you look at the two, it's literally the exact same structure on both sides. Though that ID and age could definitely just be numbers. They don't need to be strings like that. But inside XML, all of this data is automatically treated as a string, which is kind of annoying if you're working with it, because it means that you need to know what the data structure is, because you'll have to convert to whatever their native data types are. Whereas JSON actually kind of gives you a few data types right out of the box, which means you can actually kind of keep your data normalized as you're passing it around the internet. So XML used to be the data language of choice, and therefore is still a huge part of the legacy web. I interacted with it last year working with Moneris. Moneris is a big payment portal merchant. If you guys are doing anything with the web and you're looking at commerce in any way, you will be working with Moneris, undoubtedly. And Moneris still transfers data back and forth to the API through the API using XML, which is kind of annoying, but that's what it does. Whereas JSON is definitely the preferred data language amongst web applications today. So any startups that you're looking at are using JSON. We're building a brand new system for our parent company, Mintent, and it's all JSON communication back and forth. And actually everything we do, like our queuing systems, our parameter list going from our Lambda functions, because we're using AWS, all communication between any microservice that we're working with is all done with JSON. All communication is done with JSON. Even the response back to the client will be done with JSON. So just because it's quick and easy to work with, and it's better to work with it natively. All right, like I said, you already know XML. HTML is XML based. HTML is XML. HTML is used to describe the data between each block, right? So when you have a p tag, it's describing that the thing between the two p tags is a what? What's the data in between the two p tags? Yeah. It's a paragraph, right? That's what they mean. They mean paragraph. Body means body. If it's between an article, then it's an article. That's literally what it's saying. This thing is an article. Div doesn't mean anything at all. But this thing inside here is a block element. That's really all div means. It doesn't actually have any contextual value in any way. But HTML5 is kind of cleaning that up a bit. Now we're not winding up with just massive structures of arbitrary divs and spans everywhere. Now you have all the HTML5 tags available to you, like article and section, main, nav, right? Those things are descriptive. They actually explain what this particular thing is. They're important. They provide something to your page called semantic value. And basically, what semantic value means, if you hover over the word, semantic value means the data has meaning and value. A div is meaningless to a human. However, an article has meaning. And I say it's meaningless to a human, but in the end, it's actually meaningless to more than just the human. It's meaningless to Google, the thing that you're hopefully trying to rank in, right? Because, I mean, if you're not on page 1 within the first 5 listings of Google, then you're pretty much dead, right? You've heard that joke before. How do you hide a dead body? Put it on page 2 of Google, right? Because nobody goes there. So, same thing, semantic value isn't just for you, it's also for the algorithm that Google runs. Bing, Yahoo, any of those guys, they're using the semantic value of your page in order to build out certain pieces for your thing. Like when you go to a hotel, for example, if you say hotel in Google, right? See this section, this card here that it shows up? That card is appearing because we're using information. These pages have information that are providing that card with data. And they're pulling the data from like Expedia and Trivago and stuff like that using the semantic structure in order to populate things like their phone numbers, their address locations, stuff like that. They're also finding places close to you, and they're doing that using the address information that is on the page. And the reason they know what that address is because of HTML5. Well, not just HTML5, also things called schema, which is something that also helps with that. But that's all done because of semantic value. Like these places here. Notice they're all in Berry, right? Travelodge happens to be, looks like a dump, but whatever. This happens to be the top one there in that listing. And that's all being provided to you by structured data. So, HTML, just as descriptive. XML, same idea. The only thing about XML, actually you can do this in HTML as well. XML, you can literally use any tag that you want. You can give it whatever name you choose. It really doesn't matter. You can do that in HTML too. However, it probably won't validate against the W3C validator because it won't know what it is. But just keep that in mind that HTML is just XML, so you can really just use tags as you choose. All right. Working with XML data, not very hard. I mean, it takes seconds to learn, and if you've used HTML, it takes even less. So in here, I have written a couple of steps. Create an XML structure to describe a shopping cart, and then describe 2 products within your shopping cart, ensuring you list their name, price, and description about it. So I'm going to let you give it a go. Right? Just take a look at the example above. So your opening tag, make sure that your tags follow the logic of symbol naming, right? So no spaces. Don't start it with a number, that kind of thing, right? Same rules as naming a variable. Right, go ahead and create the opening structure to that and then add 2 products. Don't worry about adding a description. Just put the name and price in there. That's totally fine. And then when you click execute, if you did it correctly, it will actually validate your XML and spit it out as JSON on the right-hand side. If you did it correctly. All right, I'll go ahead and do mine. I'm going to call mine cart. Cart. I will say the editor does not do XML very well, but thank God this is pretty much the only XML structure we're ever going to build, so not really a big deal. And I mean, if you want to cheat and just do 1 product and then copy and paste it, that's totally okay. Gonna make, this one's gonna be fudge. Fudge. And I mean, what's the price of fudge, right? Price of fudge is probably about $4 a pound, I would guess. I'm gonna say 4.00. Copy that, paste it in place, and let's do taffy. You guys do whatever you want, though. That's too much money. $2 for taffy. And now I'm done. I've got my cart, got my 2 products. I'm going to click execute, and sure enough, it shows up in JSON on the right-hand side. If it errors out, make sure that your closing tag is just the opposite of whatever your opening tag was, right? But it needs that wonderful trailing slash, just like in HTML. Look severely confused, Nestor. What's up? When you click execute, is it giving you an error? So now, like, there's huge drawbacks to working with XML, and one of the big drawbacks with XML is that all this data in here is just strings. Everything you write is a string, which means that 4.00 has no semantic value, no data type as a number. That is not a number. That is a string in XML world, which is kind of annoying because I don't want to treat it as a string. You can see that it's been parsed as a string. You can see that on the other side, what the JSON structure has done to all of our data. Everything is a string. But I don't want strings. I want numbers, right? And that's the great thing about JSON. JSON actually keeps our data types the way we want it. We are limited. We don't get all of the JavaScript data types that we have. We do get a subset. But I mean, it's all the ones that we care about. All right, anybody still typing out? No? Cool, let's scroll. So, JSON, right? I pronounce it JSON. Some people pronounce it Json, right? They'd have to say every single letter. Or Json. Some people actually say Json, like they're spelling it like Jason, right? But it's not. It's Json, right? Just letter J, S, and then son, right? So why Json is so perfect for JavaScript? I mean, it's literally in the name. JavaScript object notation. It's right there for you. The two things work very well together. And next semester, when you guys start working with advanced frameworks, and you're building, if you're in my class, you'll be using the MERN stack. If you have Rich, you'll be using the mean stack. If you have Alfred, I think he uses the mean stack. I use the MERN stack because I find React is a lot easier to learn than Angular is. That's really the only difference. Other than that, it's Mongo, which is your database, Express, which is your server, React, which will be like your front end for your views and everything else, and then Node, which is your back end server language. All four of those things have something in common. Does anyone know what all four of those things have in common? Yeah? Yeah, it's all JavaScript. All four of those things communicate using JavaScript. All programming in all four of those things is JavaScript. Mongo gives you back a JSON structure that you interpret automatically as an object. Express is built in JavaScript, for God's sakes. It handles all your routing back and forth throughout your server. Node is JavaScript. It's built on the Chrome V8 engine, and it's entirely written in JavaScript. And React is JavaScript, which means you use one language for everything. Absolutely everything is written in one language. And React is even cooler because you're not even writing HTML. You're writing JavaScript to be able to produce whatever views it is that you want to produce. Right? So that makes it very, very cool. People like it because they don't have to flip-flop between languages. They don't have to change their data structures and like manipulate them. Like that's real pain in the butt when you build a server in PHP and then now you got to take whatever data you're moving back and forth and convert it to JSON for APIs or whatever. That's annoying. With the MERN stack or the mean stack, it means that you don't have to do those things because all components in there are using the same language, right? So JSON is absolutely perfect for communication with JavaScript because it is JavaScript. It's just a JavaScript object. It describes a data object which can allow the JavaScript API to interact natively with that object, right? It's superior to XML because it already is an object. It doesn't need to go through any post-processing whatsoever. And even if you do have to actually do any post-processing, it's in every single language that I can think of off the top of my head. It's literally one command. One command to convert it over to an object in that native language. Right? Like, so Ruby has a way to parse JSON into native Ruby, like convert it into a hash. PHP has a function for converting it into an array. C++ even has a function for dealing with JSON as well, though you have to include the library. But it has a function for converting JSON into an actual C++ object. Right? So every single language that I can think of off the top of my head has some way to convert JSON quickly, except for JavaScript does it right out of the gate, right? Only if it's a string does it need to actually do anything with it. All right. And it's also superior to XML too because it supports data types, and XML does not support data types. Whereas JSON, you get data types right out of the box, which means you keep your data nice and normalized as you move it about through the internet, right? So below is a list of supported data types, right? And you'll notice that it is essentially every data type we're used to using. There's only one data type there that is missing. Does anybody know what it is looking at that list? There's one data type we're missing.
Number?
No, we got numbers. I called them integers and floats, but yeah, they're numbers. But what's that? Sorry? Which is ridiculous because you can't have null, actually. Null should actually be on that list. So should undefined, technically. What's that? No? So think of like, what are these things? All these things are descriptors, right? Every single thing here you see is a descriptor. It's a value describing something. What are we missing? What are we allowed in objects that isn't a descriptor? No, array's on the list. Double is under numbers. Functions. Function is the data type. And function isn't on the list. And the reason why we don't get function on the list is because JSON for every single language is passed around as a string. Every single language, we pass it around as a string. And the reason we don't get functions on this list is because those functions would be written in JavaScript. Well, Ruby doesn't understand JavaScript, doesn't even know what the hell that is. So it wouldn't know how to execute the function, right? And PHP doesn't know what JavaScript is, doesn't care, right? So it wouldn't know how to execute the function. But that's not the only reason. You know how bad security would be if you're pulling in JSON on your server and executing random functions from around the internet? Like, that would be terrible. You could wind up with a lot of problems. So that's one of the other reasons too. Due to security, you don't get functions on your list, and nor do you need them. When you're working with API, I mean, it's in the name. It's Application Programming Interface, right? Application Programming Interface, anything functionally that needs to happen, any actual action that needs to occur, is done through the application call, right? Through the function call, through the API call. This is just data. You just need data back. But you do get some cool things. You do get objects, right? So you can actually have your JSON structure store tons of objects, and those objects can nest all the way through. You can have multiple nestings of objects and arrays and anything else in there that you want, just not functions. That's the only thing you lose in that scenario is actual functions. So working with JSON data, not extremely hard, right? Like creating a JSON structure is fairly simple. You're just basically describing the data, no different than what you did in the XML. The one thing that actually changes when you're actually describing your data is that now you have to pay attention to data types. I mean, you don't have to. You could just make everything a string. But then you're going to have to go deal with that later, right? So why not take advantage of those things? If you have a Boolean option inside your data structure, use Boolean values. It just makes sense, right? If you need to store a list, use an array. Create an array and store a list. If you have another object you're describing, do the same thing. Use an object to describe that. If you look there, I've got a JSON structure. Describes a person, this person, right? Has interests, which is an array of values. Has my bank account information. Obviously not the real bank account number, but the value's pretty close, right? But it basically describes the person, and notice we have nesting. This is all top level here. We get into the array, we're nested in, we have our list values nested in. Our actual bank account is another object inside this object that can be treated the same way as any object can with properties, just not methods, right? You don't get methods for it. So over here, we're actually going to create a JSON structure that describes a saved game state, and we can literally create whatever we want. The only key point to JSON, though, you have to start your JSON structures with one of two operators. You can either start it, which is most common, with a curly brace, right? And then it has to be closed with the closing curly brace, right? What does a curly brace mean in the JavaScript world? What type of data type is that? Nope, not a function. It's an object, right? That's a native object, just an object literal. Remember when we created object literals in week 1? No, you don't lie, you don't remember. Anyways, that's an object literal. So you can either create it and wrap it in an object, right? Or you can use this structure. And what is that structure? An array. There you go. So you get one of those two. Those two things are valid, okay? You don't assign it to a variable. Everybody tried that on Monday. They're immediately assigning it off to variables. Don't assign it to a variable. It is just a string. At the end of the day, it's being transferred around as a string. So variables don't mean anything because we can't evaluate the variable. We have no functions in this scenario. There's nothing logic parsing wise, right? What you see has to be wrapped between these two tags or between these two tags, okay? So, as you can see, this structure here, there's our opening tag, there's our closing tag. We know the thing is an object. But we could pull out just this structure here, just that square bracket and that square bracket, and have this, and that would still be valid JSON as well. So you might be like, okay, well, how do I tell if my JSON is valid? So do yourself a favor, just copy that. Command-C, Control-C, right-click and copy, though you should be ashamed of yourself if you're doing it that way. All right. Command-C, Control-C, depending on which operating system you're working on. Jump over to the internets. Type in the words JSON validator. I use jsonlint.com, mostly because it's the first option in the list. Go ahead and paste it in there. And don't click the blue button. That seems like the button you would click. Click the white button on the left that says validate JSON. And you should get a nice green valid JSON. I'll zoom in a little bit so you can see. There you go. It's green. Okay? So, let's break it. If you come up here and you attempt to assign that, right? Assigning it to a variable, and I click validate JSON, I get invalid JSON. Nice, great big red band. You screwed up. And it makes sense because, yes, while JavaScript would totally know what the heck that is, Ruby has no idea what that is. That's meaningless to Ruby. That would actually work in C++ up to the point where you hit the curly brace and then it would blow up. PHP, not at all. We don't define variables like that in PHP. They use dollar signs in front of them, right? So the whole idea of JSON, cross-platform independency, meaning that it shouldn't matter what platform you're using it on. This should be communicable, which means you can parse this, you can work with this data. It should be available to you despite whatever language it is. So we don't get variables. Can't do that, right? So that's invalid. This is also invalid. Sometimes people do this. They take off these two, and they think this is valid JSON in here in the structure, right? Why not, right? Click validate. Nope. Nope. Doesn't understand. It wants you to wrap it in an object. It has to be wrapped. There has to be some sort of container around it. You also can't have two containers, right? And that's what we're kind of doing here. Here's a container. Here's a container. Like, I can't do this. This is also not valid. We'll take this one off and we'll wrap it here. And then we'll wrap this one here and finish it off here. It doesn't like that. It doesn't understand why there's two. It only wants one, right? You can't have two back to back. Now, what I could do, if I wanted that to pass, I could put a comma there, put that there, and this here. Nope, doesn't like that either because it wants this to be named, right? It doesn't actually have a key value. So I would have to give it a key value to get it to pass. Okay? So validate JSON, right? Whatever site you want to use. I use JSON Lint. You can download packages for Sublime and Visual Code that will validate inline in your code editor and let you know if you're messing up in your code, which I recommend having, especially during tests, because it makes life a lot easier in a test if your thing is automatically parsing JSON for you. But yeah, JSON, nice and simple, but we do get the wonderful benefit of data types. Cool, let's jump back over to our lesson. And we're actually going to create a small JSON structure on the right-hand side that is going to have some nesting in it. It's going to describe a game object, and I'm going to just do this on the fly. Okay? Couple things to note. All keys have to be wrapped in quote characters. Okay? All keys have to be wrapped in quote characters to be valid JSON. So keys are these things: name, age, married, interests, bank account, ID, and balance. Okay, those are keys. Values do whatever you do for the data type, right? So Sean McKinnon is a string, so it's wrapped in quotes. Double quotes, never ever single quotes. Only ever double quotes, and no backticks. Those are not valid characters in JSON. 40, right, is a number. True is a Boolean. This distinguishes that this next thing is going to be an array, but all these strings are quoted. ID is a number, balance is a number, even though it's a decimal, right? So you can keep those data types as they are, right? Bank account is an object. That's entirely okay the way it's written too. So let's do that on the left-hand side, or the right-hand side. Let's do, first we need our brackets, right? Let's create our brackets. And we'll create a key called main player. Make sure you put it in quotes. And main player will be an object. And it's going to have a name. You can call your main player whatever you want. Actually, I'm going to call mine, make a wizard. And they're going to have some skills. Right? And what kind of data type seems best for skills? How many people say array? Cool. How many people say object? Cool. Let's do an array. That was literally just an opinion question. All right, skills, fireballs. I mean, why not, right? Oh, what's the one they actually do in Diablo? That's Nova. Frost Nova. That's what we're going to do. Frost Nova. And setting shit on fire. There you go. There's the skills. It's cool to have a main player, but maybe we should have some teammates, right? So let's, after that object, after the main player object, do a comma. And we're going to create one called teammates. I guess teammates would have two M's in it, right? It's two words, isn't it? There we go. We'll do camel case. And we're going to have more than one teammate, so let's use an array. But the teammates inside will actually be objects, right? Will they? Yeah, let's do them as objects. Why not? Just so we can actually show that. Let's do player 1 or teammate 1. That would make more sense. Let's do teammate 1. Teammate 1. There we go. And we just really need an object with a name. We're going to call them Bobby B. Baby. All right. And then we'll create teammate 2. That'll be it. I won't make you create tons more. First time I taught this class, we did this products list, and it had like 16 products in it, and the JSON object was like this big. The whole class was just JSON, though. That was boring as hell. What's a good name for my second teammate?
Reese.
Reese? I like that. What's that from? I know what that's from. Is that from Super Troopers?
No. Don't overthink it. Just back.
Oh, I know that name. That's going to bug me now. Thanks, Mo. All right. Hey, maybe we should put some health for ourselves, too. Let's go back up to where it says skills, and let's add some health. Actually, even better than that. No, let's just do it easy. Let's do 50. Nice arbitrary number.
Wait, where'd you put that out?
Just after skills. You did a comma after skills and put health. I think that's good. We've got some nesting. How many layers deep are we going? 3? Yeah, 3-ish. That's not bad. That's good enough. So today you're also going to learn something else. Actually, just out of curiosity, how many of you have used a recursive function before? Oh, that's cool. 0 people put up their hand on Monday. Nobody had used a recursive function. That's cool. We're going to write a recursive function in order to iterate through this. So if you've never written one before, you'll get to write one today. Cool. So we have our JSON object, and as you can see, it's quite easy to follow. Right, we know that we're dealing with a player, right? It's the main player, and that main player has a name, skills, the health, and the teammates that it's working with. If we wanted to, we could actually do a comma after main player and add in another one. Wait, what the hell's going on here? No, that's fine. We'll just leave it the way it is. We got a secondary player, though, if we wanted to. Got as many as we wanted to, actually. Anybody still writing? Yeah? No? No? Good? Cool. Let's scroll. All right, so working with JSON structures, same as working with object literals, right? Did you pick that up? Remember the object literals? No, you don't. Don't lie to me. They're just like the object literals from week 1. Let's jump over to, because I actually loaded it up for you as well. Bam! Comp 1073 modules.haruku. And let's go to where we actually first started talking about objects, which was under destructuring an error message. This seems like a weird topic. Now, we talked about objects there. So it was in the one before that. Maybe it was in library and custom functions. Where the heck did we talk about object literals? Object literal, not in that one. So it must be in number 4. Object literal. There we go. There it is. See how close that looks to JSON, right? Like, I mean, if you just took this part right here and started wrapping all of those keys in quotes, it would look exactly like the JSON objects, right? So if you remember object literals, then JSON should be like old hat. The only difference between the two is that we're wrapping our keys in quotes. That's the only difference. And actually, if you create the JSON, if you create an object literal, you can actually take your object literal and convert it to JSON with one command. One command, convert it entirely to JSON, and then transmit it through the internet all you wish. All right? Which makes JSON even more cool. So, yeah. What's wrong with this, Jason? You want me to validate it? Let's jump over to JSON lint. Command A, Command V. Validate the JSON. Oh, we have a problem. Oh, of course we have a problem. Why did I not see that? So arrays don't understand what objects are because they only accept list values. So these teammates, they need to be wrapped in an object. Dun dun dun. Sorry. My bad. There we go. Just put some curly braces around it. I mean, you can hit enter and make it look cleaner if you want to. Actually, you could cheat. Just copy that, go to a search on the internet, JSON beautifier, and paste it in. It will beautify it for you. Does this one? Mine does not beautify it for you. Even though the XML one, where you actually spit out the JSON on the right-hand side, I built a beautifier function for that. So that it would beautify it for you. But yeah, whatever. Okay, I don't know if that's valid. We'll have to check if it's valid. Don't copy the comments, though, because comments are not valid in JSON. I'm going to jump over to the linter. Bing, bing. Oh, I don't think I did things. There we go. Cool. Valid JSON. There we go. Mine's valid. Everybody else is valid? Mm-hmm. Oh, most of them don't. Yeah. Why are you looking so angry? You're like glaring at me. All right. Oh, then what are you? Oh, what is it?
That's more.
Your body language said otherwise.
Oh no.
You don't know. Come on, man. That's what you got to play. You're not wrapping your teammates. That's why. You gotta wrap the teammate, dude, like this. Oh yeah. Yeah. It's got to be an object. So here's the problem with an array, right? Arrays only take list values. That's it. So this and anything between it is totally okay. That's fine. But if you didn't have that, and you have, key, that's okay. The second you do this, the JSON validator blows up because it's like, this does not belong in an array. Get rid of it. I don't know what this thing is, right? Because arrays only support lists. Right. So that's the reason why it's not working. All right, cool. So make sure you hit execute on that because, and actually I think I spit something out for you when you do. If you click execute, it should come up on the right-hand side over here. And you should get the nice interactive drop-downs in order to actually see the layout and structure of it. And it's important, too, because we've got to save it. I'm saving it for you globally so that you can access it somewhere else later on. What do we got? 8 o'clock? Let's go just a little bit further, and then we'll take a break. All right, so on some occasions, we actually want to convert our objects into JSON and our JSON back into, into JSON strings and then reverse it. So when we're working with JSON structures, it's the same as working with object literals. The only real difference is that we get our JSON data generally from APIs, unless there's an exception to this, unless you're using the mean stack or the MERN stack. But if you're using like PHP, Ruby, or any of those guys, or you're maybe calling for data from somewhere and you're not interpreting it as JSON, you're just getting it as text, you will get your JSON back as a string, just a text string, which is totally fine because there are things you can do to actually convert it over to a JSON object. And if you scroll down a little bit, you'll see I have an example. So here's my JSON string. Notice it's wrapped in quotes, right? That's just a JSON string. I can't actually do anything with that. It doesn't mean anything in the real world because it's just a string. And if you want to test that, go ahead and open up your little console over to the left there, or to the right. Just grab this stuff in here, copy it, paste it, hit enter, and you'll see that JString, its current type is string. See the console log, type of JString, right? I mean, you can write it in yourself too if you want to. Type of JString, string. So that's not an object. You can't do anything with JString. There's no way to access any of the keys on it, right? Like I can't go JString name because it's not a thing, right? It's not an object. So I can't access indexes on it because there are none. It's just a string. I have to convert it. And in order to convert it, what I do is I use the JSON library, which is this thing here, and it has a couple of functions which are really important. The first function is parse, and what parse will do is it will take a string, and if it is valid JSON, it will convert it into a JavaScript object for you, which is pretty cool. One line, and you convert that string into an object, right? On the other side, if you have an object, like an object literal, say you made an object literal and you're passing around your application, or say you made an object literal that stores a score and the current equation and stuff like that, and you want to put it into local storage. Local storage only supports strings, which means you got to convert that JSON somehow, so you can actually run, and I love the name of this thing, json.stringify. Stringify will take an object and convert it into a string. And as you can see, if you console log it out, after you stringified it, you will get string. All right, but I mean, nothing better than actually going through this process and doing it. So here, this will be the last step before we take a small break. This console log that's right here, if you actually hit execute, so just hit execute underneath that block, you should see the word string there, right? If you don't see the word string, then you didn't click execute on your JSON object up above, or there's a problem with your JSON. Now we're going to convert the JSON value into an actual JSON, like an actual object. Currently it's a string. We want it as an object. So what we're going to do is we're going to do m10p2 dot, okay, m10p2 is an object. env is a property on that object. These are just objects that I make up. Does anybody know what M10P2 stands for? Perfect. Module 10, practice 2. Literally this block. Right? So there we go. Module 10, practice 2. .env, which is a property on that. .json, which is a property on that. Equals that whole line all over again. And we're going to wrap it in JSON dot. And it's a string currently. How do I convert it into an object from a string? Parse, exactly. Let's call parse on it. And whammo bammo. And then obviously we want to see that, so let's console.log that out. And I'm getting super lazy. I don't feel like typing that out all over again, so I'm going to just copy it, paste it, semicolon, execute. And if you did it correctly, you should see your main player object over to the right. There's actually a whole bunch of methods available to JSON. If you type JSON in the right-hand column and hit dot, you can see, well, there's not a whole bunch. There's a few. There's parse, stringify. You can access this constructor. There's stringit, which is one that I made up. If you hit enter on it, you can see what stringit does. I created that one. That's for actually converting objects with methods in it. It will convert everything out to a string. I use that to interpret some of the stuff you guys write. Cool. All right, so we're going to take a small break because the next step is 40 lines long. And we're basically going to work with our object recursively and break it apart. And I need a drink. So, yep, let's take 15 minutes and then we'll come back. Not stop. Okay. So we have that JSON object. So the reason why I was kind of alluding to recursive functions is because iterations, when we iterate over something, we iterate at a shallow level. And what that basically means is that we iterate one nesting deep. If we want to iterate more than one nesting, we have to actually nest another iteration. Right? So if you have a for loop, it will move through the shallow level. If you want to go a next level deep, you have to add another for loop. And in this scenario, because we have 3 nestings, we'd have to add 3 for loops in order to nest through with a bunch of logic to basically say if you don't hit another value to exit, it's a headache. And this is really the best job for something like recursion. Because recursion doesn't care how many nestings there are. We can continuously nest, and recursion will just take care of it and do what we want it to do. Our goal in this next script that we're going to write is to basically pull the key that you see and its value. So we're going to go key and say its value. Key, say its value. Key, say its value, so on and so forth. Right? Now the arrays are going to work a little weirdly because these don't have keys, these 3 things that you can visually see, but they do. They do technically have a key. Because in PHP, objects are arrays, but in JavaScript, arrays are objects. So if you think of that for a second, if this array is an object, what are its keys? Because objects have to have keys. How do we reference a value in an array? Exactly. So the keys for these array items are actually its index numbers. So it's almost as if you had a 0 here with a colon, a 1 here with a colon, a 2 here with a colon, right? And you can actually see that in the JavaScript creation, right? When we hit execute here, this thing that generates, right? Here's our main player. Here's our teammates object, right? If you click on the main player object and you see the skills, you see the 3 there. You click that and you'll notice 0 with a colon, 1 with a colon, 2 with a colon. That's because JavaScript is actually spitting this out inside the console as an object. It's treating it as an object. It calls it an array. It tells you it has 3 values. But at the end of the day, it's treating it as an object. And each one of those becomes its key. This is super important because when you're actually working with arrays, so here's my array, 2, 3, right? So I've got an array, 1, 2, 3, and if I say type of tells me what about a value? What does type of tell me? Yeah, what data type, right? It tells me the data type of the value. So if I do type of array, it should say array, right? That's what you would think. But it doesn't. It's an object. And that's because in JavaScript, arrays are actually objects. Yeah, we have an array class that is kind of obfuscated in Vue. But there's an array class that actually converts it and gives it automatic indexing numbers. Which is a little confusing at first for new JavaScript programmers because it looks like an array, it's structured like an array. But these 2 wonderful little brackets are just syntactic sugar for an object.
So you could essentially just incorporate some brackets instead of the.
That's the thing that you can't. Like it still doesn't get treated the same way, unfortunately. So if you used an array and you wanted to iterate over it the same way you would iterate over object, it would work actually. But you would wind up with 0, 1, 2 as your keys. That's the weird thing about it. Yeah.
Where this one won't show you the 0, 1, 2.
Yeah, exactly. When you iterate through using for of, then it just lists it normally. Or if you use for each, they take into effect that they know it's an object and they obfuscate that from you, so you don't see it. Yeah. So it's a bit confusing at first, but it's also kind of a benefit for us because when we build our recursive function, we don't actually need to care about it. We don't need to care that it's an array and not an object and perform different logic. We're just going to treat it the same as any object would be treated. We're going to treat it the same way. So we're going to learn a new loop that we haven't learned before. We're going to learn the for in loop. So we've learned a standard for loop, which uses number iteration, right? You basically set I to 0, and then you say, based on this condition, increment I, right? We've done that for loop. You guys have done that in every language you've worked in. Then we have the for of loop. The for of loop is pretty cool. Somebody said it's very much like Java's destructured loop or whatever it's called, where you use the colon character in order to iterate through an array. It's kind of the same idea, just you don't have the colon character, you have of, right? Does the same thing, takes an item from the array, pops it into the variable becomes available in the block. Same idea, right? We've written those a few times. Then we have the for in loop. The for in loop is a little different. The for in loop is going to, at a shallow level, take these keys and pass them into the loop one at a time as an array item. Okay? Then from in there, we will have to call our object and pass it the key in order to access the value of the key at that point. The for in loop is probably one of the most useless loops I've ever seen in my life, but it's necessary if you're trying to iterate through an object. It's just bizarre. You can make for in loops work a little bit more normal, but it requires a lot of extra code and a lot of understanding of object entities in order to get it there, and destructuring, which we will learn next semester. All right, let's start from the beginning. Step 1. Select and store the M10 PV or P4 div. So just copy that. And we already know how to select and store elements, right? Just query selector. And then pass that in as our selector. And make sure you put the hashtag in front of it, because it's an ID. What's that?
Would we put like query selected by ID?
No, that's not a thing. You're thinking of get element by ID.
Yeah.
Query selector is better than that, because query selector, it will take any type of selection, CSS selection, and will always return back an HTML element. Whereas get element by ID, get elements by class name, get elements by tag name, they don't return reliably everything that you want. This is a much better solution for that.
Okay.
Plus, this is the one that replaces all of those. Those will eventually be deprecated, so you guys should avoid using them. Yeah, same as var. There's recent discussion in the 2019 spec for JavaScript about deprecating the var scoping tag thing, because they want you to use let and const permanently. And if it's a global variable, you define it as a global. Yeah. All right, cool. So create a new UL DOM element. You might remember this from a couple of weeks ago. We created elements. So it's document dot. How do I create an element? That's right, create element. I pretty much gave it away. Create a function called print that has one parameter called obj. So function print obj. This function is going to wind up being our recursive function. And recursion in its simplest explanation is a function that calls itself. That's basically the simplest way to think of a recursive function. So you have to make sure, just like in any loop, you have some way to get out of the loop, right? Because a recursive function will continually call itself, and it can do it infinitely. And eventually, if it calls itself too many times, it reaches something. Does anybody know what it reaches? And everything goes south. What is it? I think you're on the right track. Stack overflow, right? Because you actually exceed your memory stack. So what happens when a function calls itself is this, and it's kind of bizarre. I'm going to use the function notation from math, right, as opposed to writing a word function. So here's our function, right? And we're going to pretend that every one I write is the same one. And it's going to call itself. Cool, right? And then this one's going to call itself. Okay? So this function has been called by this function, which has been called by this function. Here's your stack. Okay? Every time these things happen, they get popped onto the stack, right? So this guy is now located here in the stack. This guy's here in the stack, and then this guy's here in the stack. Stack, for those of you that don't know, is memory, right? There's an allocation of your RAM that gets allocated to stack, and that's where things like function calls go and data literals go and stuff like that. They get shoved into memory. And you only have so much, right? Like my laptop has 16 gigs. Some of you may be rocking 8. I mean, if you were super cheap, you might be rocking 4. Hopefully not, right? Or maybe you might be rocking, maybe you're using AWS cloud services, which props to you. But basically that's the way this works. So this guy sitting here, this guy sitting here, this guy sitting here. Stack is very volatile, right? The idea of stack memory is to get it in, get it out. And it's first in, first out. It's the way it works. So, no, first in, last out, sorry. So this is the first in. It's not going to leave the stack until it completes. This one's in here. It's not going to leave the stack till it completes. This guy's in here. He's not going to leave the stack till it completes. That's fine. We're only 3 recursions deep. The problem is, can this guy complete before this guy?
No.
No, because he was responsible for calling this one, which was responsible for calling this one, which means this function is not done at all until these two are done. And this one's not done until this one is done. You have a set limit of stack memory, which means the more recursive functions you call, the more you keep adding to this, and the more copies of your function get shoved into memory. So a lot of people, there's two camps. There's camps that are like, recursive is fantastic. It's a great way to go. There's nothing wrong with recursion, right? Use it fully. Then there's the camp that says, don't ever use recursion because you can reach stack overflow. You always stand the potential of stack overflow. And because of that, you should always use iterative structures. Writing much of this logic in an iterative pattern is extremely difficult. And it can be very, very time-consuming trying to figure out what the iterative pattern would look like in order to do the same thing you could do in recursion in a few lines. My feeling about this whole thing is your recursive function should be very small. Very, very small, like a few lines. If this function has other logic in it that needs to execute, you should be trying to identify what chunks of that logic you can pull out and put in their own function. Because that's totally fine for this function to go off and call this function, right? Which will get added to the stack, but immediately pop off the second it's done. So if you take your function and break all the little blocks into tiny little logic problems into smaller functions, recursion is completely fine because these things are only going to exist for a very short time and then disappear. So you're really only dealing with the core logic of your function and not copying, 400 lines into memory repeatedly through your recursion, right? Which you want to avoid. Anyways, that's my opinion on it. You might develop your own opinion. That's totally cool. All right, let's finish up. So create a for in loop that takes the OBJ and assigns each key to a throwaway value called key. A little on the nose, but whatever. So we need a for, just like an of. It's almost exactly the same. Let key, but instead of, we're going to type in OBJ. So the first time we iterate, key is going to be main player. Second time we iterate, key will be teammates, right? Because it's at the shallow level. It won't recursively dive until we set up our recursion, which we have to do by calling the function internally. So because the object has some properties attached to it from my system, we have to do a step to get rid of them. So my system is this application you guys are using to type your code in, and unfortunately my system adds some helpers onto objects that we create. We need to get rid of those so that they're not a thing. So what we're going to do, if obj key, so put the key in the brackets because it's an index reference. In front of obj key, type in the operator type of. The condition we're checking is to see if it's a function. So we're basically saying if this value is a function, which is one of my goofy things that I've added on, we're going to take advantage of our wonderful shorthand. If you want to write curly braces because you're a purist, you go nuts, but I'm going to write this shorthand. I'm curious if you know the answer to this. I want to go to the next iteration. I don't want to break out of my function or out of my for loop. I want to go to the next iteration. How do I do that? What's that? That's exactly it. Continue. Continue will not break from a loop. It will force the next iteration to occur and not continue to execute the code underneath it. That's how it works. In some languages, you have to return, which is very weird. But yeah. Step 5. Create a condition check to see if the obj at the index of the key is an object type. So we're going to write basically the same thing we just wrote. If type of obj at that key is equal to object, object. So if our value is an actual object, which is main player an object or a string? It's an object, right? And teammates is an array, right? But we know arrays are what in JavaScript? They're objects. So both of those will wind up going through and parsing in whatever logic is in here. Step 6. If it is, recall the print function and pass it our obj at the index of key. Don't change that word recall to invoke, because that's really what that should be. Invoke the print function, right? Execute the print function. Recall is not the right word. So here you can see we're calling print, the very thing we're defining. We are recursively calling it. So we're calling our function from within the function itself. We're going to call print. We're going to pass it obj key because we've identified its value as an object. So we're basically saying, hey, cool, take this object back and run it through your function again. Step 7, call continue to exit this iteration and begin the next. I'm assuming there was words after that. How do we continue? Continue, right? So here's our current logic. We call print, we pass it our obj. In our scenario, it will be our Json object. That's what we're going to iterate through. It's going to come here, and we're going to check to see what the value of that obj at that key is. If it's a function, we don't want to execute any of our code. We just want to continue on to the next iteration. Cool. So we're in the next iteration. We come down here and it's checking, hey, is your current value at this object key an object? Because if it is, I don't want to write the key value. I want to pass that back into the print and run this logic again. So obviously we need the last piece. The last piece is we're going to create a new li element, right? And we'll store it in const li. We're going to set its text, so li.text content, right? Equal to some wonderful backticks. Gotta love those backticks. key. And then how do I get the value? Yep, exactly. Index of that. The index of the object. So obj with key passed in as an index. That's the one thing I don't like. I would much rather be able to destructure this thing. So I wish I could do for let key comma value, where key was the key and value was the value. But it doesn't let you do that in JavaScript in this particular for loop, which is kind of annoying. But I mean, it is as it is. All right, last, step 10, append it to the UL element. No worries, ul.append li. We know how to do that. That's easy. That's probably the easiest step of the whole group. Well, you guys are typing that out. Stack is for short bursts of memory. Does anybody know what is when you need to store larger objects, what that section of memory is called? What is it called?
Q.
Nope, not Q. Starts with an H. Heap. Heap is for storing bigger objects. If you find memory interesting, take C++, because you will be working with memory, like, directly. Cool. I'm going to scroll up a little bit. Just a little bit so we can get to step 10. There we go. Call our print function. So now we're outside of our function definition. Our function definition is complete. We need to call it for the first time and pass it our object. Does anybody remember the name of our object? Because, I mean, it's way up there at the top and I don't remember it. What is it called? Save?
That's what I see. I don't know.
Is that what it is? Yes. No. No, it's JSON. That's what we called it. JSON. And then step 11, append the list to the M10P4 element, which is what I think you were thinking of. So M10P4 dot append UL will be the last piece. And if you click execute and it was correct, it should pop the list down here below. It will recursively crawl through and grab all the pieces of data and spit them out. So just click append, and sure enough, it should work. You are going to see some like 0, 1, 2. Actually, this kind of glitched a bit. My God, did it ever glitch. That's cool. Yeah, it glitched out a little bit. I don't think my recursion was quite accurate. I think I made a mistake somewhere in the recursion. Not that it's a super big deal, because I have a very simplistic recursive example below. And I mean, it is super simplistic, which will basically give you the same idea. All right, scroll down a little bit further. Past your 185. So it's obviously treated the string object as an object, which is interesting. Here we go. So here's our structure. You can see the wonderful amounts of nesting in here, right? And the goal is to capitalize all these letters, right? So you have to write logic that will actually go through, access each letter and capitalize it, but not capitalize the array object, because you can't do that anyways. It would just return object in capital letters, which would be weird. So you first need an actual function. Call it literally whatever you want. I think on Monday I called it lowercase abc to uppercase abc. And then it's going to need to accept something, but it's going to accept an array. So I'm just going to call my argument R. R, right? Like pirates. R. And I like this example because it's extremely simplistic. So the comprehension of a recursive function will be a lot easier to understand with this example. So just like before, we need to do an iteration. We need to iterate through the array, so we're going to use an of in order to do that. So I'm going to call it let value of R, right? So for every iteration of R, it's going to take its current item and pass it into value. That's how the of for of loop works. Just like before, we need to check that value and see whether or not that value is an object or whether it's a string, right? Because we only want to do things to it if it's a string. If it's not, then we just want to literally take it and pass it into our ABC to ABC function again if it's an array. So we're literally just going to go if, and this is nice because all we have to do is type of value. We don't actually have to pass index numbers this time. If type of value is equal to an object, right? If it's equal to an object, then we're just going to call our function again. So ABC to ABC and pass it value. And then step 5, we're going to call continue because I don't want to execute the logic that actually capitalizes the value because it's not a string, it's an array. I want to get the hell out of there. So in order to do that, we're going to call continue and we're going to get out of there. All right? That'll force us back into the next iteration. In step 6, all we're going to do is just console log the value and call to upper case on it. And then step 7 is literally just calling that to ABC and passing it in our array, which I can't remember the name of it. Strings, it's called. And that's it. And if you hit execute, you should see A to Z in capital letters within your console, if you did it correctly. And that is recursion. And I mean, if we were to draw this out, when you guys are writing that out, who the hell's all the chalk gone? But the tiniest little chalk thing, right? So here we are, we've got our for loop, right? And we're iterating through our array. It's going to pass our value, right? And the first thing we're going to do is hit one of these wonderful shapes, which is for conditions, right? And we're really just checking, hey, are you an object? That's what we want to know. If you are, we're going to pass you back into our function. Otherwise, we're going to continue, and we're going to do value dot to upper case. That's basically the simplicity of what's happening. Which means, you're going to have probably about, I think there's 5 functions in the stack before it finally starts to kill them off one at a time. But it's a very small amount of logic, so you'd have to run, I don't know, probably about 10,000 iterations of it to ever blow out the stack, which is not likely. I mean, even 10,000 iterations with loops, nested loops, would cause problems. So, cool. Feel clear on recursive functions? The good thing is it's not going to be on the test. That's the good thing. But it is something that you need to know, especially if you're into programming. I know not everybody is into programming, but taking the course anyways. But if you're into programming, recursion will save your butt quite often, especially if you have to do tree walking, which happens often, right? If you're trying to walk through nested data, understanding this concept will make your life a lot easier. All right, cool. Let's scroll down. So everything we've done so far is basically to deal with describing data. The recursive function allows us to iterate and actually parse through our data. You guys have understood now that JSON is like the language of choice. We're not going to see XML going forward. We're not going to work with XML. We're not going to do anything with XML. Everything we're going to do will be with JSON. Next week, when we actually do client-side APIs, we'll be working with JSON, okay? Because our feed will come back from JSON. If you are easily offended, please send me an email right away, because next week's lesson, we'll be working with the Matt Bass insult API, and it likes to insult you. So you do a request, and you get back a wonderful insult. They're not the nicest insults in the world, so keep that in mind. And just let me know ahead of time if that's the case. Maybe I'll just create 2 APIs. One will go to a boring news site, and the other one will go to Matt Bass's insult generator. And you can choose which one you want to use. All right. That's it for that. Let's do client-side storage. And these two things go together. It might not seem like they do, but they do. JSON is wonderful because we can pass it around the internet as a string, and all languages can interpret it. Client-side storage is awesome because we can take our wonderful JSON string, jam it into our client-side storage, and then use that in order to rebuild state if we need to on the front end. Client is stateless. This is a very important concept for people to understand. The client is stateless. What this means, in a nutshell, is if I make modifications using JavaScript in my browser, or even CSS in my browser, to any of this page, the second I refresh, all those modifications are gone. Because the client is stateless. It has no way to reliably save my changes. Unreliably, I can use 2. There's other technologies, but I mean, there's only 2 that are actually in almost every browser. I can use 2 technologies to store state. And those 2 are cookies, right, which everybody's heard of cookies before, and local storage. Cookies are used to store small pieces of data, usually things like tokens, right, so that we can verify that you've already logged in, maybe the status of your current shopping cart, just tiny little bits of data. Local storage is intended to store larger amounts of data. I think it actually stores up to 5 megs for each value, which is quite a bit of data, right? The idea of local storage is to put things that are more public-facing, insecure data, but relevant and personal to that particular client, that particular user, right? So that would be things like, you know, when you guys are working with Google Docs, have you ever wondered why when you lose power or lose internet, sorry, not power, but when you lose internet access, why your document's still intact? It's because Google Docs actually writes to your local storage, stores the document into local storage, and then when internet access is available, it writes the current changes over to your internet access. Even smarter than that, it actually uses diff operations to do it, which is pretty intelligent. So it's only writing the actual difference between the 2. It's never actually storing the whole document. It only stores the actual changes between each one. And that's important because internet is shaky, right? Like, can't guarantee access at all times, but you're going to be pretty pissed off if you've just written 89 pages of your thesis and now you just lost 89 pages because the internet went out, right? That would suck. So they need some way to store it. So what they do is they store it into local storage for you. Or they might store it onto a hard drive, ask you if they can have storage permissions, and then store it actually on the hard drive. But they just use local storage. Cookies are more for like tiny pieces of data, usually states, right? You're logged in. You click the button. You dismiss this ad. You've received this notification. That kind of stuff, right? Just tiny pieces of data that you just want to be able to store for the user to provide them more convenience. They're only ever meant to be convenient. That's it. Local storage and cookies are only meant to be used for convenience. They are not meant to be a reliable state. What do we use as a reliable state? We don't use the client, the server. Exactly. Because as developers, we can rely on the server. We can actually maintain state on the server by saving to file storage, by saving to databases. We can actually create what's called persistent state by saving to those points, right? So the client is unreliable. So anything you do in the client, you're really just doing for convenience. You're just trying to give a better user experience. That's all you're doing it for. There's no other reason that you're doing it because you can't reliably maintain it. See this wonderful little cookie icon? I'm not sure if you can see it because it's super, super tiny. If I click that, that disables cookies on my machine, which means if you're relying on cookies on my machine in order to validate me or verify me, sorry, they're gone because that thing actually disables cookies and I get none of your cookies. Which means, yeah, my internet experience is going to suck ass from this point on, but that also tells you that don't use it in order to store important things. Only use it to store convenient things for the user. If the user shuts off local storage in your Google Docs and they lose their 89 pages of an essay because they lost internet access, that's their freaking problem, not yours. You just create the convenience. You don't need to manage it. It's not your problem. It's theirs. All right? Cool. That's my public service announcement on client storage. Now, incidentally, there is local storage, there is cookies, but there's also WebSQL DB, IndexedDB, and there's a few other ones. There's large storage as well, which is like I can request from you 2 gigs of your hard drive space and then dump 2 gigs of data on there. But you have to actually say it's okay. It's like it's a two-way communication. I ask you for it, you say yes, and then I go ahead and start dumping data into it. It's not something that happens automatically, though there are. You got to be careful. Read those messages that pop up on your screen. Don't just click OK, because some of them are asking you questions like that, and you need to give them the appropriate response. However, if you want to know whether or not a browser supports something, you can click the you can go to caniuse.com. Caniuse.com is a fantastic way of telling whether or not a browser actually supports a feature. So WebSQL, for example. WebSQL. Here's WebSQL. WebSQL was a great idea. Fantastic idea. Google's like, this is the thing that's going to revolutionize the whole internet. You're going to be able to type SQL queries right within your browser and actually work with SQL, relational databases within your browser. And Internet Explorer and Firefox said, fuck no, that's not happening. We're not doing that. We don't want any part of that. So as you notice the wonderful red block here, that red block is because they said no, we're not doing WebSQL. Chrome adopted it, Safari adopted it, and I mean, it's surprising. That was pretty bold considering Chrome currently makes up almost well over 80% of the internet. Most users are using Chrome. 80% of the internet users are using Chrome. The other one is divvied up between Firefox and Internet Explorer, and then Opera. I mean, you must really like painful experiences. And Safari is generally for mobile. Now that's desktop though. That's desktop numbers. It would be interesting to see what the mobile numbers are. Because it might shift, because I don't know, how many people own an iDevice, like an iPhone? Yeah, how many of you installed Chrome? Right, that's my point. Most people just use Safari because there's nothing wrong with it, right? You just open it up. But on my Mac, I'm using Chrome because I don't like Safari that way, right? So it'd be interesting to see the mobile numbers. Either way, the point to take from this is that not every technology you're going to use is automatically available to you or available in the version you're expecting it to be in. Whereas local storage, as you can see, is reliable unless you're using Opera Mini. Opera Mini was a browser that they rolled out to the Nintendo DS years and years and years back. I don't know if Nintendo still uses Opera Mini. It might. I think it might even use it on the Switch. But local storage is not available in that device. All right. Actually, Nintendo DS, when it first came out, used used a browser called Conquer, which not very many people use, but is around. Might even be in this list. No, it's not. The Baidu browser is, though. Canadians won't know Baidu, but you guys will, right? You guys have used Baidu? Do you guys use Baidu? Has anybody heard of Baidu? It's like the Asian browser for like it's Asian Google. It's huge. Yeah, it's huge in Asia, period. Yeah. So I work for a company that scrapes the internet, right? That's what we do. We scrape search engines. And Baidu is literally like on par with Google in our scraper for keywords being managed. Maybe it's a generational thing.
No. It's your pronunciation thing.
Oh, how do you pronounce it?
Okay. I gotcha.
Is it a popular browser? Or sorry, yeah, and a popular search engine, right? Yeah.
I have to be the only one.
It's like, you guys don't use Google then. That's not the preferred one?
Yeah. It's blocked.
Oh, really? That explains a lot then. That explains why that's probably the second one. Like, for example, we collect almost a terabyte of keyword data a day, every day. We have like petabytes of data. And when we're collecting that data, I would say 70% of it is Google. 20% of it is, I'm going to say it wrong again, Baidu.
Yeah, I do.
Baidu. Right? And then the rest is like Yahoo and stuff like that, which like barely hit the market. I think Bing's like 3%. It's like really low. But most of our collection keyword data comes from Baidu and Google. It's pretty significant. All right, cool. So that's Can I Use? Very handy site when you're trying to actually look at this stuff. Of course, now I have to navigate back because I didn't have it open up in a blank. Cool. So the first piece we're going to talk about is cookie. No, we're not. Actually, we're going to bypass that. I'm going to leave that to you guys as homework. Look over this cookies thing. Follow through. It's cookies are a pain in the butt. Okay? Cookies are a pain in the butt. I'm not going to put cookies on the test. We're not going to use cookies very much. We will use them next semester in advanced frameworks. We'll use cookies. Okay? The one I want you to know, though, is local storage, and I don't want to run out of time. So let's take a look at local storage. So local storage, believe it or not, if you open up your developer console window, I'm already using your local storage. Those wonderful little IDEs that I put on your screen, just to make life convenient for you, when you guys finish typing them out and you hit execute, in the background I have a script that actually copies the contents of that and it puts it into your local storage for you. And the reason why I'm doing that is because I don't want you to refresh your screen and lose your content, right? I also don't want you to leave your computer and come back to it later and all of the stuff you just worked on be gone, right? So the way I do that is I persist your state unreliably though, right? But that's your problem. If you have local storage turned off, that's a you thing. That's not a me thing. So I persist your state by copying your contents into local storage. If you want to see what's in your local storage at any point, if you open up your developer window, now I'm going to warn you right now, if you're using Internet Explorer, Safari, Opera, Firefox, I have no idea where this thing is. I only know where it is in Chrome. In Chrome, it's in the developer tools. You click on application. You will see on the left-hand side, there's a bunch of different things. There's like manifest, there's service workers. Service workers will be, if you're on a site, you know how sites are now coming up saying, hey, would you like to have notifications sent to your desktop? You'll see those under service workers. There's clear storage. Do not click that. If you click that, you'll destroy all the cookies and all the local storage. So all your hard work you did today will be gone. Actually, all your hard work you did over the last 14 or 10 weeks will be gone. If you click on local storage, in here you will see the domains that are relevant to you in local storage. And you'll notice that there's our domain, and here's the things we've saved. Now, you likely have a lot of them, right? Because you would have anywhere from module 1 up, right? So you should have a whole bunch of them. If you want to see what their value is, you can literally just click on the value, and down below here, it should show you what the value is sitting inside there, which is kind of convenient. There's also session storage. Session storage is usually written to from the database. You won't have any session storage currently. There's web SQL because Chrome thought that was a good idea. There's IndexedDB because the whole internet thought that was a good idea and then they abandoned it. But it is supported in there. And then there's cookies, but we don't have any cookies currently stored. There's also cache storage. Cache storage is for pictures, CSS, stuff like that. That information will get stored in there. potentially, if I had caching enabled, but I don't, and application cache, which is a different thing as well. There's lots of places to store data. Lots and lots of places to store data. All right, come back up to local storage here. So we're actually going to write something to local storage and create a new value in our local storage. And local storage is extremely easy to work with. Not hard in any way. Let's scroll up. All right. Setting a local storage key value pair. So obviously, if you want to actually use local storage, we need to set a local storage key value pair. We can use the local storage.setItem method. You pass in two arguments, the key and the value. The values are always strings. I think you can use numbers, but generally I think they get interpreted as a string either way. So when you pull it back out, you would have to parse it as a string or as a number. All right? So first thing you need is the local storage. Now I did this on Monday and we found out that it was kind of silly. We were doing basically const my storage equals window.local storage. Because it's on the window object, you can literally just call local storage. You don't need to do window.local storage, so there's no reason for us to set it in a variable, so ignore step 1. Here's our structure here, right? This is the object, and I want to actually store this object into local storage. Now you can go ahead and change those values if you want, so that they're relevant to you, okay? And our step 1 is basically going to be set a new item and store the above structure in it. And it's really simple. All you're going to do is type in local storage in camel case, right? So local starts with a lowercase l, storage starts with an uppercase S, right? Dot set item, again in camel case, and that is a method. That method's going to take two arguments. It's going to take a key and a value, right? The key, call it whatever you want. I'm going to call mine Sean. And the value, I can't just say obj. I have to convert it to a string. How do I convert this to a string? Not to string. Stringify on what object? Goggendeep. Starts with that. Starts with a J. Yeah, Jason. There you go. It's pronounced Json. Dot stringify. Takes one argument, right? Just our obj. And then once you do that, you can go ahead and click execute. And you can hit execute 1,000 times. It does not matter because it will only ever create one instance of it. If you already had a value in there under the key Sean, you will overwrite it. Sorry, I'm going right back to it. Don't panic. There you go. I'm going to go over to application, and I can see right here, there's Sean. And what's kind of interesting, when you store JSON in there, if you click on the value, it actually gives you an interactive structure, even though it is a string. Which means the browser itself understood that it was a JSON object and is parsing it, which is kind of neat. I found that neat. I don't get out much. Cool. Anybody still typing? Are we good? Let's move on. You'll notice that this is basically CRUD, is what we're doing now. We just created an item. We need to be able to read that item, right? So actually accessing the value in local storage, you can do window.local storage. You don't have to, though. You can do just local storage. The way we access the value is get item. I mean, that's intuitive. And then you pass it the key. You probably would have figured that out pretty fast. So if you come down here where it says accessing local storage and parsing the response, I'm just going to drag this over. I don't know why the word strings is in there. I'm assuming we're just accessing local storage. So all we're going to do is just console.log local storage.get item, and then whatever you called yours. I called mine Sean. You might have called yours something else.
Yeah.
You have a different value?
Step 1, step 2. Yeah, like steps.
Yeah, you have tons, but at the bottom you should have your key and your value.
Yeah.
You might have to scroll to get there. The reason why you have all of these things in there is because each one of these little IDEs I create for you, I store in local storage for you so that you don't lose the value in it.
Yeah, I just put one to start my value so I don't have to scroll.
Oh, is that what you did? You did one so you didn't have to scroll down through the list? Probably a good idea. I mean, you can clear. It's just your work, but I wouldn't.
If everyone wants that, then that's fine.
Yeah. Go to console, hit execute, and you should see it over here. But what you will notice right off the bat is that it's not interactive. Why is it not interactive? Why can I not interact with that?
It's just a string.
Exactly, because it's a string. Can't interact with strings. Needs to be an object in order to work with it. So that's read, right? So we've created. What method do we use to create a local storage item? Set item, there you go. And how do we read a local storage item? Get item. Now we need to know how to update. Does anybody want to take a guess at how we update a local storage item? No, we don't actually need to do that. How we update it? We call set item again and give it the same key. So that's your warning. Because if you call your item and use set item with the same key, it won't warn you. It won't say you're about to overwrite this thing. It'll just overwrite it. Okay? So just keep that in mind. If you want to actually remove it, sorry, we can actually do that too. If in your console, just type in local storage and .set item. Oh, wait, actually, no. I have an example. Don't do that because you'll overwrite it. We're going to actually use it down further. At least I thought we do. Maybe we don't. Or did I bypass it somewhere? Oh. I must have... Oh, no, I see. I did an example here. That's basically what I did. All right, well, let's do it anyways then. So local storage dot set item, pass it whatever it is that you want to pass it, and then the value, just do whatever you want. So I'm going to do Bobby B. Bobby B, baby. Bam. And now if you go to application, you'll notice the value that you had in that spot has changed. Notice it hasn't given me any warning. It didn't tell me that I overwrote it. It gives me no information whatsoever about what I've just done. Which obviously, you can see how that can be fairly destructive. And one more reason to realize that this is not a reliable store, right? And obviously the last thing you're going to want to do, so you can see here that it's changed out to Bobby B, baby, right? The last thing you're going to want to do is actually remove items. And listen before you do this. I don't want you to accidentally clear everything. If you call .clear, it will clear the whole local storage entirely. Purge all of it. Which means all of your values will be gone. And you won't be able to get them back. Once they're gone, they're gone. That's it. Because again, it's not reliable. It's not a database. It's not saved offsite anywhere. If you clear, it's gone. It wipes them out. If you want to remove just one item, right, just a singular item, you call remove item on local storage. So let's go ahead and remove our item. All we have to do is, I've already added my storage there, so we might as well use it. My storage, or you can just do local storage. Let's try and find two. Remove item, and then pass it whatever the key is. Actually, I think I called my name, didn't I? Yep, I called it name. So I'm going to remove name. Now, when I do this, if you look under application, I've got Bobby B, baby, underneath the name, right? When I do this, that's going to disappear. It's going to be gone. And I'll show you that live. Here it is. You can see the value in there. If I click execute, it's gone. You choke holding me? I can't tell what's happening here. What do you mean?
Can you remove multiple items?
I don't know. I've never tried. Like if you can give it a list?
Yeah.
No.
Well, you don't have name in there anymore.
Doesn't matter. Like I can try it with the other order, but I don't think it matters. Oh, maybe. Okay, hold on. That's kind of interesting. So let's do M10P4, M10P5, and we'll see if they go. Nope, M10P5 didn't disappear.
So it's only the first one.
Just the first one. So it's ignoring anything after that. But it didn't blow up either, which is kind of weird. But
What if you like put plus sign and okay.
put the plus sign in anything? Like you're adding the two? That's concatenation. So now this would be M10P4, M10P5. You would have to have a key that was M10P4 and M10P5, right? No. All right. The wonderful button is there. Get code. Spit it out. Doesn't have to work, as usual. Just paste it in the lab submission. Get your points.
Do we need to finish the cookies part though?
Do you want me to do it?
Yeah, because I couldn't get it to work. Maybe I did something wrong.
Alrighty. Yep.
Everything wrong.
If you want to go, you can, or I'll go through the cookies part, because we are kind of early. But 1 second. What's up?
We have this different. Like in the one that you have only 1 line. That was.
Oh, you have that, and I only had strings, eh?
Mhm.
That was down here where I did this,
that one.
right? Yeah, I bet you that's because... I'm not even sure where I got all this stuff from. Let's see here. Oh yeah, there we
No,
go.
you got it.
Get your local storage, get our person value. Right. So I was missing all those pieces. That's fine.
Mhm.
That's fine. It still works otherwise. So, all right, let's do the cookies. Just because we have a few minutes, we might as well just run through. If you don't have time and you want to go, that's fine. Feel free to go. But I'll run through these cookies if you want to see this part. So obviously cookies, not like num-num cookies, right? Cookies as in browser cookies. I mean, unless you've been under a rock for the last 25 years, you may not have heard of cookies before, but I imagine most of you have. There's been good news about cookies and there's been bad news about cookies, right? And most times, bad news about cookies is just myths. People don't understand how they work. They get freaked out, so they go about trying to install things to disable them, when really cookies do give you a lot of good things. However, cookies can also give bad things too. The way cookies work is a cookie is domain specific, but cookies can travel on links that are on your page. So if your page uses a Facebook login, for example, Facebook can tell that they're using the login because it will communicate with Facebook, pass the cookies to Facebook, and let Facebook know that it's somewhere. Usually it will pass the refer, which is you, and say, hey, this site has this thing on it, which means it can track your user. That's part of what the whole GDPP thing was about, and why people were getting really super mad about being tracked on the internet. And now you can download all these wonderful tools in order to avoid tracking and stop that kind of thing. But of course, it does also lend to not necessarily a great browser experience, because cookies are used to provide convenience to users, and cookies are also used quite a bit in authentication. A cookie can be used to authenticate one request to another, and most authentication systems work with cookies. So for example, Amazon. If you disable cookies, you will have to sign in on every authenticated page. Imagine how terrible that would be. Add item to cart, go view cart, re-log in. Pay for cart, log in. Add your credit card information, log in. Literally every single authenticated page you have to log in, because your cookie would only literally last for that singular request and then disappear. So you need cookies if you want to have a half-decent experience working on the internet. All right, setting cookies is kind of annoying because it's not like local storage where you literally just set a key and give it a value. You have to actually give it a query string. And the query string has the key in it, and it looks like this format that you see here where it says key1 equals value as a string. That is one cookie. So for example, here you can see setting a cookie. Hey boy, what's up? You have to escape the value because cookies do not support spaces, semicolons, attribute symbols, anything like that. You can't do that. They only support non-spaced alphanumeric characters. If you want to use non-alphanumeric characters like a space, you have to escape it. The cool thing is JavaScript gives you this wonderful function called escape that immediately will add in the slashes and escape the characters for you, so you don't have to worry about it. It'll do it for you immediately. For example, the space in here and here will be replaced with the 20% HTML escape character, which you probably have seen in browsers, like when you see the URLs. Sometimes you'll see like 20% D blah, blah, blah. Those are escape characters that are being jammed in there. And it will do that for you as well. If you want to see that, actually, if you just open up your console, go ahead and copy that line, paste it over, hit enter, and then call escape string like that, and you can see what it does to your actual string. So anywhere there was a space has been replaced by the 20%. The exclamation mark, because it is not a valid alphanumeric character, has been escaped with this %21, which actually is a representation of that. Again, 20% for the space, what's up? The 3 question marks, they're all represented by %3f, %3f, %3f. And it's HTML escaping that is occurring, not letter escaping like you would see in regular expression or anything like that. To actually set the cookie, you do need a couple of pieces. One is optional, the other one is not. The first one is the actual cookie string. It needs to look like key equals value as one string, okay? In here I'm using backticks to create the string. These backticks are actually creating the string for me. But at the end of the day, let me grab these pieces here. We'll grab this backtick just so you can see what the string's going to look like. That's what the string gets converted to. That's what actually gets assigned to the cookie. So here's my greeting, right? Equals the message that I have with the what's up. That is the actual cookie being assigned. I will say that assigning cookies in JavaScript is much more difficult, like in client-side JavaScript, it's much more difficult than doing it in Node. It's way easier to do in Node, which is kind of interesting, but part of that is because of the cookie library. All right, I think the best thing we can do is actually do it. So let's create a cookie name. So you can do whatever you want. I'm going to do const cookie name 1 equals name. And then I'm also going to do const cookie value 1 equals Sean McKinnon with a space. If you want to do the second value in cookie name, you can do const cookie name 2 equals age. And const cookie value 2. And because cookies only work in strings, you need to put your age in a string. I'm just assigning these to variables because I find it easier to build the cookie strings this way. Escaping the first cookie value, just do const cv1 equals escape. Cookie value 1, or you can just wrap cookie value, like whatever the thing is with the escape, that also works. And const cv2, same thing, escape cookie value 2. Create the first cookie with an expiry passing. So each cookie has to be created individually. You can't just put them all in a row and shove them in. They won't get added properly, which is kind of annoying, but that's just how it works. part of the reason why I hate this part of this lesson is because it doesn't work the way everything else in JavaScript works. Cookie is a property, but the second you assign a value to it, underneath the hood, it's taking the value and adding it as a new cookie immediately, and you get all of that obscured from you, which makes it a bit confusing. But it's document.cookie equals, use some backticks. The first piece you need is the cookie name, 1, equals CV1 with a semicolon after the actual value. Cookies can take an expiry date, and the purpose of the expiry date is basically to say this cookie's lifespan is X amount of time. You are allowed to have cookies last for as long as you want, but generally a good rule of thumb is to make them expire after usually 30 days if it's authentication cookies. That way if the person hasn't logged in for 30 days, they are forced to re-log in the next time. You can't just assume that cookie, right? The way you do expiry, it's very simple. It's just expires equals, we'll need a $sign and the brackets. And in here we can just do new date, and then date takes the string. And the format that seems to work the best is year, month, and day. Date seems to like that the best. And what it will do is it will return back a correctly formatted date string. Creating the second cookie, just go ahead and copy that and paste it. Change cookie name 1 to 2, change CV 1 to 2, leave the expiry date the same. And then when you're done, go ahead and click execute. Change it over to application in your tabs. Click on cookies, and you should see age and your age and name and your name. Plus, if you pull that out, you'll see the expiry date that's set and everything else as well. What domain it was set on, all that important information. Setting cookies, come on. Local storage was so much easier, right? Way less steps. But cookies you will use. Generally, I have never set a cookie in the client before. No, that's not true. I did when we were building some weird authentication. But most times I don't set the cookie in the client. I set the cookie on the server. So in the server itself, I'll create the cookie and then send it into the client from the server, and it will get created. That's usually what I do. But you can cook works too, but you can create it from either side, the browser or the client. What sometimes people will do is they'll create it in the browser, and they'll create one on the client, and then they'll use the two to verify that the person's who they say they are, and that the session has not been hijacked. There's like a whole website called OWASP that actually deals with browser security.
So is that why ours don't show up? Maybe it's because I have mine exactly like that, but they're refreshed, they don't show up.
Even when you click the little refresh icon like this one?
The new ones don't show up. I don't think I have any.
So the other thing it could be is your security settings. So if your security settings are strict and you're accessing, so there's a few things that could be. Right now, my security settings are just normal, but I'm in a not secure browser, right? In order to make this secure, I have to change this link to HTTPS so that it's using SSL. If your security settings are saying only sites using SSL can write cookies, which is an option, you won't get the cookies. So you can try changing to HTTPS and see if you can write the cookies. That might fix it.
If I go to cookies in use, my cookies are there, like for the site.
Oh, okay.
So it shows up there, it just doesn't show up in the application like that.
Oh, that's weird. Well, they're there then. Well, we'll find out in a second because you'll be able to pull them. What you can do to check to make sure they're there, if you go to console, this is weird, but document.cookie, the same thing you use to write them, if you enter it in and just hit enter, you'll see your cookies in the console. They should be set and ready to go.
I have an empty string.
You have an empty string?
Yeah.
What if you refresh your page and do it? Just refresh your page and type document.cookie. Sometimes it needs to go through a full request in order to be available, depending on your security settings. Yeah, this is kind of one of the reasons why I hate this lesson.
Yeah, if it's not
And yeah, it says cookies in use allowed, and it shows the 2 cookies I made.
Right.
It's not appearing in the.
It's likely security settings that are disabling or not allowing your cookies to be accessible. Which could be any number of things causing that. You could have Chrome extensions. Are you using Chrome? Yeah, you could have Chrome extensions that are disabling it. There's tons of different things. Which leads back to the whole scenario. Client-side storage is not reliable.
Yeah.
Because there's so many different implementations of it. It's very difficult to guarantee it. Right? And that's how you get your cookies with document.cookie. And I'm not going to get into it. You can actually take a look through this thing if you want to. But as you'll notice, this is a string. This is not the same string as what you get back from local storage. That's exactly what you get. If you want to break that into an object so you have a name and the value pair, you have to create that. There is no parsing function or anything like that to convert it for you that I know of off the top of my head. You have to actually convert it yourself into something more workable than that. Incidentally, cookies on the server, much easier to work with. They're also easier to set. And a lot of that has to do with security. It is possible that your browsers, for whatever reason, are locked down so the security is not letting the cookie be set. But that's how you set them. Yeah. And if you want to double check that, you can always go to MDN, type in cookie, and look at the document.cookies for the examples of it and read through. If you do find that we missed something, I would really appreciate
I don't think so.
if you can just send something back.
Copy and pasted pretty much from what you had it, so.
And that's pretty much exactly what was on MDN.
Yeah. I mean, I can see it be created, so I know the code works. I just
Yeah.
can't view
You
it.
probably don't have security settings to save.
It's some security setting that's been ramped up for whatever reason. And because I do so much web development, it's possible that mine have been lowered. So just to make my life more convenient for whatever reason.
So I'm just curious about the assignment. Like,
Yep, let me just stop the